This tutorial is brought to you by PE Prep Engine. Free study guides and practice questions at peprepengine.com.
Week 6, Lesson 6, Acoustics and Vibration Control. 2 supportive knowledge topics that reward the same habit. Read the handbook's tables and figures instead of hunting for an equation. Acoustics has no algebraic sound formula at all. You combine 2 levels with a lookup table, and you rate a room by reading the NC curves. Vibration is the half with real physics, and it reaches into Chapter 2, Machine Design, Natural Frequency from Static Deflection, and the rule that isolation only starts once the frequency ratio passes root 2. Concept 1. Sound is logarithmic. Sound power level compares a source's acoustic power to a fixed reference and reports it in decibels. Because the scale is logarithmic, an enormous range of power, a large fan versus a small diffuser, collapses into a narrow band of levels. The key point for the exam: the handbook gives this as a table, not an equation. There is no sound formula to derive. You read values off the page. Setup: combining 2 levels. You take the difference between the 2 levels and add a fixed increment to the higher one. 0 to 1 apart adds 3 decibels. 2 to 4 adds 2. 5 to 9 adds 1. 10 or more apart adds nothing. The quieter source is masked. Notice there is no 10-log equation on the page. Combining is purely a table lookup. Solve. 2 70 decibel fans. The difference is 0, so add 3, 73 decibels. Not 140 and not double. Doubling the acoustic power raises the level by 3 decibels. If one is 70 and the other 76, the difference is 6, so add 1 to the higher, 77. And a source 12 decibels down adds nothing, it is masked. You never sum decibels directly. Always work from the difference and the table. Concept: noise criteria. The NC curves are a family of reference limits, 1 per octave band. You overlay a measured spectrum on them, and the rating is the highest curve it touches. So the single worst octave band sets the entire number, not the average. The background sound design guidelines give target levels by room type. That is a table you look up. And attenuator or duct lining sizing is an insertion loss table lookup. There is no NC or silencer equation to compute. Concept: the isolation physics, and it sits in Chapter 2. Model the machine as a single mass on a spring. Because the weight equals the spring stiffness times the static deflection, the natural frequency depends only on that static deflection. A softer, more deflecting mount gives a lower natural frequency. How much force gets transmitted is set by the magnification factor, which depends on the frequency ratio R, the disturbing frequency over the natural frequency. And isolation only begins once R passes root 2. Setup: sizing an isolator. The selection guide is a table. You enter with the equipment type, its speed, and whether it sits on a slab or a long floor span, and it hands back a base type, an isolator type, and a minimum static deflection. Say it calls for a 1-inch static deflection under a fan running at 1200 RPM. That deflection feeds the Chapter 2 physics. Note the split. The deflection table is Chapter 9, but the frequency formula is Chapter 2. Solve. With G and the 1-inch deflection both in inches, 1 over 2 pi times the root of G over static deflection gives about 3.1 Hertz, a natural period near a third of a second. The fan at 1200 RPM drives at 20 Hertz, so the frequency ratio is about 6.4, comfortably past root 2, and the mount isolates. A stiffer mount would raise the natural frequency and push the ratio back toward resonance. Traps: 5 of them. 1. A softer, more deflecting mount lowers the natural frequency and improves isolation. The distractor says a stiffer mount isolates better. 2. 2 equal sources add 3 decibels, not 6 and not double. 3. The NC rating is the highest curve the spectrum touches. The worst band governs, not the average. 4. Isolation needs the frequency ratio above root 2. Below it you amplify, and at 1 you sit on resonance. 5. Acoustics has no sound equation. Combine by table, rate NC off the figure, size attenuators by insertion loss lookup. Quick recall. Sound power level is referenced to 10 to the minus 12 watts, and you combine 2 levels with the +3, +2, +1, +0 table. The NC rating is the highest octave band curve the spectrum touches. Vibration isolation starts from the selection table's minimum static deflection, which sets the natural frequency. 1 over 2 pi times the square root of G over delta, and you want the frequency ratio to clear root 2. Acoustics is lookup. Vibration isolation is that one formula. Next up, Lesson 7, Piping. From noise and vibration, we turn to the pipes themselves. The heat a hot water line loses, the recirculation flow that keeps the tap hot, and the L, Z, and U bends that absorb thermal expansion. 2 clean-worked examples. Everything's at peprepengine.com. Cheat sheet, worked solution, and a quiz attached here. If the course helps, subscribe.
The full study guide with every equation and common exam trap is free at peprepengine.com, link in the description. Structural, civil, and electrical series are coming soon. Subscribe so you don't miss them.